This is Kirsten Lyons. The coastal wetland I had in mind during development of this protocol is the St. Clair Delta, near where I live in Michigan. The delta is indicated by the red circle. The objective at the ecosystem scale of monitoring is to examine available natural heritage and hydrological data to determine variation from historic or desired conditions to evaluate the health of the coastal wetland using an appropriate assessment tool to predict possible trends and to support research and decision-making for what conservation, restoration, or management actions might be warranted. Coastal wetlands can be of many different types depending on their hydropatterns, primary water source, associated water bodies, climate, substrate and soil, vegetation, permanence, extent, and salinity. It's important to identify, delineate, classify, and characterize the types of coastal wetlands in the area of interest to be monitored so that a baseline type and historic range of variability can be established, sources and causes of inputs and disturbance and stress can be identified or estimated, and changes over time can be modeled and forecast. The U.S. Fish and Wildlife Service's National Wetlands Inventory Wetlands Mapper allows the user to characterize, quantify, and visualize wetlands in the United States quickly and easily on the web. The National Wetlands Inventory uses what is commonly known as the Cowardin system of classification to classify and characterize wetlands. Use appropriate natural heritage and herbarium databases to become familiar with the common wetland indicator plant species and natural communities for each of the wetlands classifications. In Michigan, for instance, the Michigan Natural Features Inventory describes natural communities and typical associated vegetation for most wetland types. Paired with the University of Michigan Herbarium online database, the user can become familiar with common obligate and facultative wetland vegetation for each wetland type. California, Colorado, and many states have similar tools for developing baseline information. Once properly classified and characterized, the coastal wetlands should be assessed for functional value, current conditions, habitat quality, existing and potential stressors and disturbances, and influencing context using the appropriate wetland rapid assessment tool for the state or the region. The rapid assessment is helpful in comparing the wetland to reference historical and desired conditions and for identifying the coastal wetland ecosystem's overall trends and patterns. Other common features of wetland rapid assessment methods include evaluations of landscape context and buffering, hydrology and hydropatterns, physical structure and extent, degree of intactness, and soil and water chemistry. Most rapid assessment methods include a scorecard to assist with judging its ecological integrity and how well the wetland is functioning. As Chrissy mentioned, at a landscape scale, it may be possible to map common, dense, and widespread invasive species such as Phragmites australis in wetlands with remote sensing tools. Exploratory, higher resolution, and more detailed surveying for invasive species and densities or for upstream disturbances such as fire and debris flow at the ecosystem level may be done visually on foot, via watercraft, or semi-remotely via drone if parts of the wetlands are inaccessible or a large area is to be surveyed. Digital mapping and visualization products for invasive species monitoring may include geographical information systems if staff, technical, and budget resources permit, and there are several citizen science invasive species monitoring and mapping tools available. It is important to monitor and manage widespread invasive species at scale in coastal wetlands. Because species such as Phragmites australis are ecosystem game changers, meaning they modify the habitat to suit their own needs. Next, Anisha will discuss site-specific monitoring for compounding disturbances in coastal wetlands.